All right, you want to just go ahead and get started?
Is mine another slide?
I don't know. We can check. All right. Hello, everybody. Thank you all for coming. Yeah, we're very grateful. I know it's week 8, so it's rough. But this will be recorded too. So let's go ahead and move forward. This is the event code if you want it. Let's leave that up for a second. Okay, moving forward. So today we're going to be talking about what infrastructure as code is, going through a configuration as an example of that, talking through what CDK is, so I'll leave it as an abbreviation for now, and then going into Terraform and AWS SAM as alternatives to CDK. And then finally, we'll do the demo as we normally do. Okay, so let me pass it off to our awesome intern Nick here to do this. All right.
Yeah, so just to like first get the context going, so with what cloud infrastructure is, it's basically like all the resources that can make up the cloud. So anything that's like hardware and software related. So like the like four most important parts are basically like all the servers, like the actual physical computers that make up the server. The networking, so like all the first of all the equipment and all the software that's needed. So oh shit, sorry. You can just close that. Yeah. All right, nice. So yeah, like all the networking that handles like basically connecting to the server. So things like load balancing, which we've talked about before, and also things like network switching, all that. And then like the actual storage, the actual data on the physical architecture, and then finally like the software. So like the GUI or like the graphical user interface, the VM or like all the virtual machines that are needed to run the server, and any other tools that are needed to access the infrastructure. So these basically are the four main needs that encompass like what a cloud infrastructure is made of. So just to get started, here's like an example of like just some hypothetical cloud infrastructure. So I guess I'll move the okay. So starting off, like you kind of see that we have three tiers, like one, two, three. And so just to start off, we have like the presentation tier, which is basically kind of like the front end, which is made up of like the HTML, CSS, JavaScript, and it's running on, an AWS EC2 instance. And then the second tier would be like logic tier, is kind of like the back end, which processes all of the user requests, like when you're on a website and you want to like, get data from it, and then also like generating responses to those requests. And so it's basically handling like communicating with the database to achieve or store data. And it also runs on AWS EC2. And then finally, we have the database tier on the bottom, which is basically, it handles storing and managing all the data. And it allows data access through like, it allows the logic tier to access the data in the first place. And so one other important thing to mention is each the presentation tier and the logic tier both come with um, auto scaling and load balancing that I think we probably mentioned before. But again, like auto scaling is just like it just handles how many instances to run based off how much like load there is. And again, load balancing is just being able to balance different like requests onto like each of the instances. So like not one instance becomes overloaded. Um, yeah. So to create this infrastructure, this specific infrastructure, with all the three tiers, presentation tier, logic tier, database tier, and all instances that come with it, all the load balancers and all the auto scaling groups, we have to set this manually through an AWS console. And so if we just have to do this once, like it can be a little cumbersome, but it won't be like a huge issue. But like other than that, can any of you guys see any problems with always having to manually set all this up? Anyone have any ideas? If not, then we can start with the first one. What if we want to set up this exact infrastructure again, but in another environment? Say like we're a company and we have this running somewhere in like the US, but we also want this to run somewhere else internationally. Do we really want to have to run through managing this all do the AWS console all over again? This can be take up a lot of time, and it's also very error prone because we might mess something up and like not initialize something properly. So that's one big problem. Another one is what if we want to like expand this infrastructure? When we want to like customize something or add something, so like things like caches or queues, things like firewall rules or certificates. If we ever want to expand on this infrastructure and be able to like make it more complicated based on our needs, it could be very like error prone and also very like um take a lot of time to have to manually do this through like an AWS console or something. So one general trend that we can see through all these problems are that having to have this infrastructure set up manually is not very scalable. If we ever want to like duplicate this environment, or if we ever want to expand on this environment, the bigger it gets, like the more issues and the more time it'll take. So it's very not scalable. It's only good if it's something that's like small and only one time. So generally, this is not a good case for a lot of reasons. So again, like just to reiterate, the infrastructure has a lot of components. So, all the operating systems, database connections, storage, all that. Again, developers have to regularly maintain, setting up, updating all these individual components. And so manually doing so, again, like I've already said this, but is very time consuming and can also be very error prone. People can make mistakes. You might set up something incorrectly, and it might like cause a lot of errors and a lot of debugging. So the main topic that we'll be going over today is basically going to be a solution to all of this. So what it is called infrastructure as code. It can also be abbreviated as IAC. Um, and so what this kind of is you're kind of just managing your infrastructure as code. So like that image that we saw before where it was like, is there a way to go back on the slides? Okay. So like kind of like this what we see here, instead of having to like manage like each of these one by one through like a shell or something, we can have like all this configuration instead described in like a single code file that code basically is, it just tells you what you kind of want from all of this. So again, using code to create your infrastructure, pretty analogous to like you have code to create an app or you have code to create a program. Here we have code that we want to create some kind of cloud infrastructure. And so another analogy is like kind of like how when you run source code, it creates the same binary file every time. If you run something like C++, it'll compile it to some binary file that some machine code that what is actually understandable by a computer. The same kind of thing happens when you write infrastructure as code. It'll kind of create the same environment every single time, which is really good. So instead of manually managing everything through something like an AWS console, we can express our desired infrastructure through code. And so there are many reasons why this can be useful, and they kind of relate to like why having to manually set up one infrastructure had a lot of problems. So one thing is version control. So again, like if you guys know, like using Git and GitHub, all the benefits with version control and maintaining some kind of like code base comes with infrastructure as code because now we're writing because now we're writing code to describe our infrastructure. So things like being able to store the history of it, being able to roll back to previous versions if we need to, like say for like compatibility, there's like a legacy version of an app, or say like something goes wrong and we need to roll back to something that was working. And other benefits that usually come with like why do you have version control in the first place for maintaining code repositories. Another thing is faster and safer deployments. So again, I kept reiterating that having to manually set up infrastructures is very time consuming, very error prone. With infrastructure as code, this lets us recreate infrastructures in different environments very quickly, and with less errors because again, we just define everything in our infrastructure as code. So it's just a machine that like run through all like the configurations we want, and then tell our cloud provider to set up like an infrastructure based off that instead of us putting in those directions manually. So it's a lot faster to like duplicate an environment somewhere else. And because it's like a machine running through those requests, it's always going to produce the same outputs instead of us doing it one by one. And also documentation. So one thing is that with infrastructure as code, your infrastructure state is actually documented and kept up to date automatically with every change that you want to run. instead of having to, again, this is how they did it before IAC, where you have to write your infrastructure on some sort of document or Confluence page. Confluence is just like some tool for like collaboration kind of whenever you made a change. So like the latter sounds very cumbersome, but the former is handled because we set up automation through IAC. So another analogy that is very like good to think about is thinking of it like the blueprint of our infrastructure. Because again, we've been saying like infrastructure as code is kind of like setting up the configurations for what we want. It's kind of like writing a blueprint for what we want. So like you give detailed instructions to the certain cloud provider about the infrastructure you want created. And these instructions leave very little room for error and can replicate exact copies of what we want. And so these detailed instructions will be written in code. It's very diverse. You can do it in JSON, YAML, HCL, or even like languages that you might have already used before, like Python, Ruby, or JavaScript. So it's very flexible in that regard. So the specific tools that are most popular out there are AWS CloudFormation, which we'll be actually talking about shortly, which is, well, I mean, it's in the name. It's for AWS, Deployment Manager for Google Cloud, Resource Manager for Azure, and there's also a tool called Terraform, which is open source and it's different with regards to that it can create an infrastructure on basically any major cloud provider. So with the first three, if you write something in any of these, are pretty much restricted to that specific cloud manager. Like if you write infrastructure as code using CloudFormation, it's only going to work on AWS. You can't use it for anything else. But Terraform is unique in that one code can kind of like run anywhere, kind of like Java in that regard. But yeah. Okay, so oh yeah.
So like, if you wrote something like your infrastructure with AWS, like, is there like an advantage of one over the other, or is it just like, is there a reason you would want it to be like able to work on multiple, like on Google Cloud and AWS? Is it,
I guess it normally comes by like if like your company needs to because it's sort of kind of like you don't want to put all your eggs in one basket. Maybe it's like due to like certain like rules from like the certain cloud provider, you want to be able to have your cloud running on multiple different services instead of just all putting it all like handled by AWS. So you guys just want to diversify in that regard. Um, but yeah, generally it's not really that applicable, I would say, to like if you're just making like just a personal project, it's probably more like maybe like political reasons potentially, or like policy reasons based on like the cloud service providers, and maybe like availability on countries, right? Like I'm not too sure about that. But
Yeah, the main thing is just if you want, like in any company, build a multi-cloud approach, you'll basically be able to use multiple cloud providers and not just AWS. So basically, we just
yes. So yeah. Um, but yeah, moving on, we're kind of gonna go off like not like a tangent, but sort of, in that we're gonna describe like declarative versus imperative coding, which kind of relates to how infrastructure as code is generally written. So just to start off with imperative programming, this is the most popular programming paradigm, which encompasses pretty much the most popular languages used right now. Again, JavaScript, Python, C, C++, Java, and kind of like most of these languages pretty much are all like imperative programming languages. What this is, it's like, so imperative kind of comes from the word emperor, which means issuing out commands. You're telling the computer what you want to do. You're like issuing out commands to a computer, which defines a control flow. Control flow is kind of like a word to use like how your programs are like going to run. So think of it through like control structures like loops, conditionals, function calls, recursion, etc. You're kind of dictating how your program is going to go through something. Like, let's say I want to get, like, you want to solve a problem and I want to make like a loop to do it. You're dictating that the program's going to iterate through a loop a certain amount of times to do a certain amount of things to get to some certain end goal. So yeah, like it's kind of like, again, like you write statements one by one and a program's going to do something based off that. So going over like an example, like imperative style code in JavaScript. So let's just first like introduce like an array of passwords. Again, like in JavaScript syntax, like const is kind of just like defining like a constant variable that can't change. And then like the variable name is called passwords, and then in the square brackets, is kind of just like, again, arrays. And then like each of these strings will be like a different element in the array. Pretty similar to like if you use like C++ or Java before. It's just that like the syntax is not as verbose, but again, we're just creating an array of strings. Let's say we want to make it so we only want to get passwords which contains like more than 9 characters. Like this is probably for an app where you're like making an account and like certain password rules are always like, oh, like has to be greater than like X amount of characters, or like your password can only like has to have like numbers and stuff like that. You guys like probably know about that like when you're making an account. So let's just say in this example use case, we just want to filter out the passwords we have to characters that are just 9 or more. There's just like some hypothetical example. And so again, pretty simple, right? Just define a new array to contain our new list of passwords greater than 9 characters. If you're unfamiliar with the JS syntax, let is just like a way of defining a variable. And then here's just like a for loop, and we're saying define like just an integer named I starting with 0. Again, it's a for loop. I has to be less than password length, but they're just looping through all the passwords. Again, I plus plus increases I by 1 for like every iteration. And so here we're saying like we're just gonna grab the current password that we're currently on in our password array, and we're just saying if that password has a length greater than or equal to 9, let's add it to our new long passwords list. Are there any questions on this?
I guess the small one, not super important to the function, but is there
Yeah.
a reason that we just like that password is like const and not let?
No, it's just style, because const means you can change it. Let means the variable can change as a it's just style. Like in this particular example, if you just said let, it's gonna do the same thing. It's just like you just put it as const because you don't want it to actually change. But yeah, good question. But yeah. Oh yeah, and then last passwords dot push is just a JavaScript method for lists to just like add it to the array. So one thing I want to emphasize, this is very imperative style. We're explicitly defining each and every single step. We're explicitly initializing one variable to contain the passwords that are all greater than 8 characters, so long passwords. We're explicitly defining it to loop over each password. And so we're explicitly telling it how we're modifying the control variable. The control variable is just the iteration variable I, where we're explicitly saying start I as 0, explicitly saying I has to be less than passwords.length, and explicitly saying like every iteration we just increase I by 1. So there's an explicit initialization of the variable to contain the password at index I. In this case, we're explicitly saying, let's grab the certain password from the list at index I from like our passwords list. And so again, we're explicitly defining the control flow by a conditional. If the password length is greater than or equal to 9, then we'll push it onto our long passwords list. So we pretty much define the entire control flow of our program. We're telling that our program is going to do a for loop. Inside the for loop, we're telling it it's going to do an if statement every time. And then in that if statement, it's going to add to that long passwords list. So this solution is like pretty generally like pretty simple. It's kind of like the imperative way of thinking, where you're just defining all the control structures, and this is how we're going to solve our problem of getting all the passwords that are longer than 8 characters. Does that kind of make sense so far? All right. So then, yeah, again, like the key ideas, we have to tell the computer each and every step, exactly how and when it would be done to accomplish our end goal of filtering our password list. And this is kind of like how like most people think about, or like it's most commonly thinking about programming anyways, like telling like each specific step or how to solve a problem. All right, so then here's where we'll get to something different that you may or may not have seen before with declarative style, which is a different way of dealing from imperative style. So again, with these different programming paradigms, you achieve the same goals anyways. They're just done in different manners because you think about how you solve the problems from a different approach. And so there are pros and cons to both like imperative and declarative style. There's no one size fits all. And so kind of the starting like what declarative means is you're constantly defining what things are. So instead of imperatively where we're issuing out step-by-step instructions, we instead declare what we want, usually through some process or function. But the key here is we're only saying what we want. We don't actually specify too much how we want it because we don't actually specify the control flow. Okay, there's a typo there, but it should say control flow. So it's kind of like saying, if you think about in our example of getting all our passwords that are greater than or equal to 9 characters, with declarative style, you kind of abstract away from the imperative style, where imperative style are going to be like, okay, how do I solve this? Let's make a for loop. In that for loop, let's make an if statement, and so on. With declarative style, you don't think about it where it's like, I'm going to solve this with like making a for loop and making all that. Declarative style is I'm going to solve this by trying to tell the program what I want, and the program will figure this out for us. And so just to introduce like some popular declarative styles like SQL for databases, regex like regular expressions that you'll see a lot in 35L, logical based programming like Prolog, and also if you've ever heard of functional programming, most if not all of them are mostly declarative style. So here is an example of declarative code, and again, it's also in JavaScript. So one thing that's interesting to note is that like you can kind of see like even in the same programming language, you can have different styles of coding. It's not just like the programming language you use can only be used in one style. It's just that generally like an imperative language you'll be used to think imperatively, but even then, like in JavaScript, you can think about it in other paradigms. So the difference here is, let's say we generate a list of passwords filtered only for passwords greater than or equals to 9 characters. The same thing as before, but instead our code is just this one line. Again, we would create a constant called long passwords, and then we're saying passwords.filter. So for those of you that do not know, in JavaScript, you have like a filter method that takes like an array, and in that filter method, you can describe what elements you want from that array. That's not like filter means. Like you want to filter out the ones you don't want. In this case, in our filter method, we're saying the password has to be greater than or equal, or the length has to be greater than or equal to 9. So that's kind of basically what's happening. We're saying dot filter, and we're passing in something that says the password's length has to be greater than or equal to 9 characters. That kind of helps us filter out all the passwords that are shorter than that. So the main thing that I want to emphasize here is that we're declaring a list of passwords, which will only be passwords of length greater than or equal to 9 due to filter function. So the difference here is that in imperative style, we had like a lot of lines of code, right? We had a whole for loop, we had a whole like if statement. In this style of code, instead, we're just defining what we want, and then it's up to JavaScript how exactly filtering works. The implementation of filter is again up to JavaScript. Again, it could still just be the exact same, where it just goes through a for loop with an if statement. But the point here is that we ourselves don't have to worry about that anymore. We don't have to worry about, oh, I'm going to make a for loop, and in that for loop, I need to make an if statement. We don't think about that anymore. Instead of thinking about how we approach our end game, or sorry, our end goal, we're just thinking about what we want. In this case, we're just telling JavaScript what we want. We just want a filtered passwords array, and it's up to JavaScript to kind of decide how to handle it. Does that idea kind of make sense? Again, if you guys have any questions, like how exactly this code works, feel free to ask. But if not, then the main idea is again, it's kind of up to JavaScript to figure out how this array will be processed. We ourselves don't have to write that anymore. We just use the method and hope it, well, I mean, it will work. Yeah, that's kind of with like declarative stuff. Does that make sense so far? All right. So again, key ideas, we never explicitly control anything anymore. So there's no looping, there's no conditionals. Again, we don't use control flow at all here. Instead, all we did was tell JavaScript to give us something through a filter method and it's to script how our long passwords are actually generated. So in essence, we kind of abstracted the way a lot of how. So we're kind of thinking in terms of like a higher layer of extraction where we're just thinking about what we want. But with imperative, you actually have to dig into like how this is actually done. With declarative, you don't do that. You don't worry about that. You just use what the methods are given to you in order to declare kind of what you want. Does that kind of make sense? Again, this is kind of like an analogy where it's like in imperatively, like the person like actually goes into like every single detail, like what exactly what employees he exactly wants, what materials he will use to build and all that. But then declaratively, like they're just saying that they just want a new castle built. It's kind of the same theme. Like when you want to get those list of passwords that are greater than 9 characters in imperative language, you have to specify every detail how exactly that's done. In declarative, all you told JavaScript was I just want like a filtered passwords array. And it's kind of like the difference between them. Like declarative, they're just saying like you're just telling the programming language, I want a castle built, but it's up to the programming language to actually define everything. For imperative languages, you can't just say what you want. You actually have to go into the details of how you get it. Is that yeah. Okay, so the reason why we kind of went through all this, there are pros and cons to both. So back to thinking about infrastructure as code, imperative will give us more flexibility in how our infrastructure is actually configured. But this can mean a lot more errors and a lot more work on our end. Again, back to the point of generating a list of passwords. Imperatively, we have the advantage of telling the program how exactly we want to solve our problem. We want to do it with a for loop. We want to do it with an if condition in the for loop. Again, there could have been other ways you could have done that exact thing. Maybe like a while loop instead. Maybe like a ternary operator instead. Who knows? But the point is, we had the flexibility to decide how we want to solve the problem, and imperatively, we had to dig into those details. But then declaratively, we kind of just would tell the program kind of what we want. That was kind of just up to the program to figure out everything on their own. So at this point, if we use declarative, we kind of tell the program what we want without specific instructions on how to achieve our desired results. And this fundamental reason is why infrastructure as code is written declaratively, where we just tell the code what we want from our infrastructure without going to the details of how to set up. So with declarative programming with infrastructure as code, we just tell it, hey, we want to set up like an AWS instance that like has like this IP address of something. And so we just tell it what we want, and it's up to what we're using, such as AWS CloudFormation or Terraform. It's up to those tools to actually do like the nitty-gritty details of the actual like order of instructions to give out in order to achieve what we want. So does tying in all that sort of makes sense. So just an example of an EC2 instance configuration, and this is written in JSON. And even though like you don't understand like what all these specific terms means, you can kind of see like what I mean by declarative style, where we're not saying anything like how anything is done, right? We're just defining what we want. We want something of an AWS EC2 instance with properties like image ID this, instance type that, and so on and so forth. We can immediately see that we're only defining things we want, but we're never actually saying how to get it. If we were doing this in an imperative way, not only would we have to like figure out what we want, but we also have to issue out the exact instructions, the exact control flow that is needed to successfully achieve all of these configurations. It's kind of like back to the example of manually setting up an AWS instance through like, or sorry, the example of setting up an infrastructure on your own through like the AWS console. You have to issue out all the instructions yourself. Declaratively, we don't have to do that anymore. Instead, we just say what we want, and it's up to the programming language to figure out what's the best way to get it. So yeah, again, like there's abstract underlying details. We just specify our end goal of what we want. So yeah, does all of that kind of make sense? All right. All right.
Okay. So kind of building upon that, right? Let's go through an example of how we can actually build infrastructure with code with AWS. Okay. So yeah, their core service for doing this is called core CloudFormation. And the general idea is that basically you can kind of well, one of the advantages is that you can visually see each services as you kind of create them, and then you can see the relationships between them. So yeah, the idea is that you can kind of model the relationships between your AWS services and then use either the graphical interface or edit the CloudFormation template to get it to your liking, and then use that. Okay, so kind of tying back into the infrastructure as code as a concept, right? With CloudFormation, we we meet this requirement because it's an example of us actually creating a template to store code, and we can version control of templates. So we get all the advantages of version control. Okay, so what does it really mean to create a cloud permission template? So on the right here, it's kind of hard to see. There's like an example of what a typical template would look like. So generally, things that you're going to want to look out for are these resources here, as well as any metadata and conditions. So those are basically what are going to tell you like the specific services that your template will need to create, and then kind of when to create which services, and then the metadata associated with those services. So generally, you write your template either in JSON format, which is what that template is, or YAML. Yeah, and this is, I think, a little bit clearer of an example of what the interface would look like. So basically, let's just say you wanted to create a new instance or something. You can do it from this menu on the left, or you can basically choose the template type, scroll through here, and then under resources, basically create a new entry for EC2. So the advantages of using CloudFormation over kind of just going creating the code yourself or creating the infrastructure yourself are that you can kind of visually build the infrastructure if you want using the kind of menu here. And then you're allowed to export your infrastructure. So if you want to share it with a friend, right, you can just export the template. And then so long as they have this, they can just paste it in and it'll automatically kind of configure or set everything up until like you have to build it. But it should preview kind of what it'll look like here. And to upload it, the button should be somewhere. Yeah, so and then the other great thing is that AWS has a bunch of templates that they've created for like a very common architecture, right? So you can just import that and then get started like in minutes with an architecture that involves multiple services kind of interacting in a nice way. Yeah, and then so this kind of approach does come with some disadvantages, right? It's not perfect. So specifically, it's kind of cumbersome to edit like granular configurations. So for example, if you need a specific IAM role, like a permission role, that allows you to allows like one service to communicate with another and only read maybe certain data, it's kind of tricky to set that up, especially with the user interface here. If you know what you're doing, you might be able to get it to work with the template. But like it's just a matter of kind of knowing the specific fields and configuring everything properly, which can be difficult. Yeah, and then the other thing is that like obviously this user interface here is kind of limited, right? Like we see there's some sort of load balancer, and it's related to this web server in some way, right? And then these are related to the security groups, but it's not very clear what like the actual ties are through just like using the pipe permission interface. So generally, what you'll see is that like managers and like non-technical staff will be the ones using this because they can kind of download a template that's already working and then kind of visually confirm it. It looks like what they want it to, and then just spin up the resources they need rather than going in and actually editing it. So, does that make sense, everyone? Okay. So kind of building off of CloudFormation, there's also a notion of like SAM. I guess it's kind of a service, but it doesn't really have like an interface like CloudFormation does. The basic idea behind SAM is that it builds upon CloudFormation, and it allows you to kind of create resources that have multiple sub-resources under them. So kind of going back to this example, if we wanted to create like a Lambda function, for example, and maybe a database, just like we did last time, you could do it with a single node instead of two individual nodes using SAM. This is essentially just an extension on CloudFormation that makes it easier specifically to deploy serverless applications. Okay. And then I've listed the CLI on here. You don't necessarily have to create a template through that CloudFormation interface. You can do it directly through the command line. You can actually create any service directly through the command line if you wanted to. But yeah, you are allowed to basically use the CLI directly to create multiple services with SAM at once. Okay. So yeah, like I mentioned before, it's a little cut off there. But basically with SAM, you can go ahead and create our entire backend that we talked about, right? With the API gateway, Lambda, and database. and IAM roles necessary with just a couple lines of code. So I think I have, let me see, second, I have it right here. So basically, this is all that you would really do. You would just kind of specify that you're using this particular transform, which signifies that you're using SAM. And then instead of kind of saying AWS Lambda, you use the serverless notion, again, signifying you're using SAM. And then they have specific properties that you pass in that are different from the Lambda properties. Generally, they'll be more or less the same. But by signifying it this way, they kind of already know you want to use this kind of pre-prepared comment template. So they basically allow you to do it very quickly. So generally, SAM will be better for use cases where you are certain you're going to be using working with like a serverless infrastructure model. So, for example, if you're creating an API for a database, or maybe it doesn't even have a database, it's just a web API to serve some sort of like static data. If you're creating like working with some of the other AWS services like SNS, which you haven't really talked about, we talked about way back when. So like a notification pipeline. If you want to kind of like watermark data as it's uploaded into AWS storage, that's another kind of great application for serverless. Yeah, and then with SAM, over CloudFormation, your templates, I mean, this is very short, right? And you're provisioning 3 services that more or less can function as a full backend. So that's the kind of appeal with SAM. It's if you want to create infrastructure and you want to do it quickly and concisely. Okay, does that make sense? Okay, so let's get into what CDK is. If you want to do this, or I want to do this, but okay. So CDK stands for Cloud Development Kit. And basically, it's a relatively new addition to AWS. It's an open source kind of framework for writing CloudFormation templates using existing programming languages. So this is kind of like the meat and bones of AWS's infrastructure as code. Because you're not writing a template, you're actually writing code. So what does that really mean? Well, before we get into an example, let's kind of break down 3 main concepts that you need to know. So there's a notion of an app. This is basically the highest level kind of container of a CDK application. And then under an app, you can have multiple different stacks. So generally what you'll see is maybe you'll have one for your front end, one for your back end, or if you're deploying multiple different apps, right, you can have, or multiple different like versions of that app, you can have individual stacks for that. Maybe like you need a specific language and a specific stack or something. And then there's a notion of a construct. So these are the individual building blocks that are used to kind of build up that stack. Okay, so here's a very simple application using Python, it looks like, to create a CDK application. So what we can see is that here at the top, they're importing specific components, or not components, sorry, constructs from the AWS CDK that they've already installed. So specifically, it looks like S3, which is just cloud storage, and then CDK as a whole. And then here, they're defining a class that's extending upon the stack. So again, a stack is just like kind of a full self-sufficient part of an application. And then here, they're basically just creating a new S3 bucket. And then at the bottom here, they are creating a new CDK app, and then creating their stack once the app has been initialized and giving it this particular. Okay. Does that make sense to everyone? What's happening here? So by doing it this way, effectively all this is doing is just creating one S3 bucket. But by kind of storing it in code, they can export that code, and like anyone can really run this and create that same bucket. Okay, so this generally you'll see CDK used by actual engineers if they need to edit like a stack, or if they're debugging something or adding a new feature. Generally, CloudFormation itself won't be good for that because of the reasons I said before. Yeah, and this is really great for version control, right? Because it's you can leverage like your kind of code IDEs like autocomplete, assuming you've installed the CDK stuff. And you have version control, assuming you're committing this code to some sort of repository. Okay, and then another thing I'll mention is that you actually can export this as a CloudFormation template directly, like in JSON or YAML. So I mean, in this case, it's not done obviously, but it's just a single, so not tricky. Okay, it's time. All right, I'm going to pass it off to Nick to talk about Terraform.
All right, so yeah, as we mentioned earlier before, like all of these tools are specific to AWS, but Terraform is unique in that it allows us to write for any, like, to create any infrastructure across all major cloud platforms. Um, so it uses something that's specific to like what Terraform is called HCL, which just stands for HashiCorp Configuration Language. And it basically describes the infrastructure's final state without specifying the exact steps to get there. And so internally, like Terraform handles managing like the execution order, like all the resource dependencies, and handles any infrastructure changes that are needed in order to reach like the configuration that we want. And so what paradigms is something? Yeah, exactly. So yeah. Um, so kind of like the two key points of how Terraform works is it has config files, which kind of describe what desired infrastructure we want, and then something called a state file, which currently describes what the infrastructure is right now. So this kind of sounds weird, like why do we need a state file? Why don't we just need config files? And so the point of it is that basically Terraform wants to keep the config files and state files the same, right? Like config file is like the infrastructure we want, and then state files describes like what the infrastructure is currently like actually set up at the moment. So obviously, like ideally, we want these both to be the same, but how Terraform will work in a lot of cases is Terraform, or like you want to tell Terraform due to config file to kind of change the configuration. And so Terraform is going to do some work to make the config files and state files the same again. So its main job is kind of to create, modify, or delete infrastructure as needed so that the desired configurations that you want are met. And so Terraform handles this for you, where it executes API calls to your cloud provider to, again, create, modify, destroy any resources as necessary in order to eventually get to the point of where we actually want. So it's kind of like Terraform doing the imperative theme where it's telling like the actual cloud provider how to actually do these in order to get what we want. And so once the infrastructure has been created / modified / destroyed to match our config file, then our state file will be updated to reflect our current infrastructure. And so the state file and the config file will be matching. So kind of like the main like steps to in terms like Terraform are first like the writing stage where you're defining like the actual resources you want. You're kind of defining what infrastructure you actually want to see. And the next one where Terraform does for you is kind of the planning stage, where Terraform will create an execution plan, which describes like the infrastructure it will make based on like the existing infrastructure and its configuration. So it's kind of like saying like Terraform is planning what changes it will do to your current cloud infrastructure in order to get to the desired end goal that you define in the writing stage. And then the last stage is applying, where Terraform is actually performing the proposed operations in the correct order. So these are two like useful commands. One is called Terraform plan, which again is creating the execution plan and letting you preview the changes that Terraform is going to make to your cloud infrastructure. And so what this is actually doing is it's basically comparing the desired configuration that we want, which is stated in the config file, to what the state file actually currently is. Then Terraform apply will actually modify our infrastructure so that the config files and state files are now the same again. So it's kind of updating the state file in order to match what config file that we want. So it's kind of like more of like a diagram, like what happens when you're actually running Terraform apply. So again, we have these two different files, the config files, which denotes the desired infrastructure that we do want. This is kind of like the to-do list of like the changes we want to do. And the state file is just what our infrastructure currently is as of right now. And so when you run Terraform the apply, it'll kind of check the differences between the state files and the config files. And then, so that's kind of the first step. Then it'll move on to see if there's actually a difference between the config and state files. And if so, Terraform will make the proper API calls to your cloud provider in order to modify the current state of your infrastructure so that it matches the desired state. And then once it does so, then the last step will be to update the state file so that it's updated to reflect the current infrastructure configuration. And so in the end, it'll make it so the state file will now match with our config file. So again, there's kind of like the blueprint analogy again, where the config file is like the blueprint of what we want, and then the state files represents like what actually currently exists. And so Terraform always handles making sure that our config and state files will always match. So like sorry.
Sure. Yeah, so some of the advantages of using Terraform are that it can be used with any cloud provider. So because the market is a little volatile right now, generally companies are moving to a multi cloud solution. So Terraform is probably a good choice because of that. I'll also say with Terraform, like Nick pointed out, this arrow here is not done by CloudFormation. So if somebody goes into the console and changes the infrastructure, CloudFormation will not change the kind of the code version of that infrastructure. But Terraform will. And then so Terraform is pretty good. Some disadvantages though are that the code may be a bit longer because it's kind of platform agnostic, right? And maybe more difficult to kind of get those granular permissions that you would with AWS. And then another thing, I'm not actually 100% on this one, but if you are working for a company that's using AWS, you almost certainly have like enterprise support. So you can, if you're writing CloudFormation code, you can kind of get support where you need it. With Terraform, it may not be as streamlined of a process. Okay. Any questions on Terraform? All right. So yeah, I know that was a bit long of a lecture portion, I guess. We're gonna quickly jump into the demo though. So this demo is actually not too long. But this is the link to it's the same repo as which I was in. And we will reconvene in about half an hour to do it together. Okay, so I just resumed the recording and I am sharing. So let's go through this together. So first things first, I'm going to open the repo here. So I've kind of already done some of these steps, and they're a little bit cumbersome, so we're not going to do them together. But let's just quickly explain them, since they're explained here. So first things first, you're going to have to install Python. If you have a Windows machine, you can do it through the Microsoft Store. Otherwise, you can just download it online, which is, I think, how I did it. Make sure that you check the box that says add to path, because otherwise they're not going to be able to use Python without manually doing that. And then the next thing you're going to need to do is download the Amazon Python SDK. So I believe this can be done with just by running this command here after you have installed Python. And we recently found out that you're going to have to install the AWS CLI. So I will add a link that explains that later today. But it should just be a couple commands. Shouldn't be too tricky. So once you've kind of done that, the next step would be to actually create a role that you could use to basically simulate or give your computer access to interact with the AWS console. So we're going to open up AWS and then log in. And then we are going to open up IAM. So you can search it up there. So this again just stands for Identity, Access, and Management. And we're going to go and create a new role in this case. So I'm going to click Roles, click Create Role. And the entity that we're going to be using, let's double check. So I don't get this wrong. Sorry, in this case, we're going to create a user, not a role. We will assign, just go ahead and create the user. We will call it CDK live. And this user will basically, essentially what our computer is going to do is it's going to sign in with these user credentials. And then assuming the user has the correct permissions, it'll be able to create resources. Okay, so we're going to click attach policies directly because we want the user to have certain permissions. And then we are going to give it full access. So this is kind of dangerous. Generally, we'll not want to do this, but just for simplicity, we're going to do it now. So we just check that and click next. And then finally create user. Okay, awesome. So now that we've done that, we need to go and give our user access or give our computer access to log into that user. So to do that, we're going to want to click on the user, click on security credentials, and then click on create access key. In this case, we're going to be doing it through our command line locally. So we can click command line interface and then let me double check this. Yep. And then we just check the box and click next. Okay, we can skip this. Okay, so this is the only chance that we'll have to do this. And I'm going to delete this access key after I finish this recording so that nobody else can sign in with it. But secret, this is the actual value. So let's copy this, and the next step would be to open up this specific file on our computer. So if you haven't installed the AWS CLI yet, this file will not exist. And once you install the CLI, as some great people pointed out, you will have to run the command AWS configure to create this file. And you can skip all the steps of that if you'd like, or you can actually paste in the access key when it actually asks you for it. But we're gonna, since I've already done that, we're gonna go ahead and open that up. So I'll open up a new folder here, and then we need to go to my home directory. So that would be under program files. I believe it's user. Well, let's see. Users here, sorry. And then my name. And then here is AWS, and then this config file. So I'm going to just open it with a notepad for simplicity. Okay, I may have to delete some of the existing security keys here, but that's okay. So we can see that under dev admin, right, we have a secret access key ID and a regular key ID. And this is where we're going to want to paste in those values from the IAM console. So we'll copy this, paste it there, and then copy this and paste it here. Okay. And then the last part that we'll keep in mind is that this part in the square brackets is the specific username or the profile, I should say, that kind of corresponds to these credentials. So I'm going to save this file, and then I'll leave it open for now in case we need it. We can press done here. And then everything should be set up locally to actually connect and interface with AWS. So the next step for us is going to be to run this npm install command here. You should have Node installed from the previous workshops, but if you don't, you would need to install Node.js. And then once you've done that, you're going to want to type in this last command. So I will, let me open up not that, I'll open up the cloud repo. Okay, I'll create a new terminal, and then we will type in that, assuming we've run this npm install command, which I've already done. I can run it again, but it won't do anything. I will run this command. Paste it in. Yeah, and you can see it's giving us a photo. So that means it's installed. Okay, so once you've actually set up your environment, the great thing is that the rest of the steps are very, very straightforward and very short. All you need to do is to basically specify your specific account and then just tell the CDK to build. So what we're going to do is open up the week 8 folder, and then under Cloud CDK, we see there's two files here, Cloud CDK stack underscore backend, and then Cloud CDK stack without the backend. So let's kind of look at what each of these are doing. So this first one requires us to provide an account ID and then some GitHub credentials. And then it has a class here with some details that we'll get into in a second. So first things first, let's go ahead and provide these details. So the best way to kind of get that would be to go to the console. If you click on your username, you can copy your account ID from here and then just paste it in. And then this GitHub owner should be the GitHub, basically your GitHub username, assuming that you forked the repo, this particular repo into your own GitHub repo. If you haven't done that, I'll quickly show you how to do it. So if you go to back here, and then open up the main repo page, this fork button will allow you to kind of create a copy of the repo in your own account, and then you can just copy your username, paste it in there, and then the repo here should just be the link to the repo, I believe. So that should just be this. Copy that, paste it in. Alrighty, and then we can save this. So now let's look into what this actual CDK code is doing. So we could say at the top, we're extending upon a stack. So this is kind of a full self-contained part of our application. And we can see we're importing ECR from this AWS ECR that's under Cloud CDK. And we're basically just saying, create a new ECR repository with this particular ID. And then here we're saying, create like a link to GitHub with these particular credentials. And then here we're saying, create a GitHub connection with, we're basically just reusing, let's see. We're saying create a connection to this particular GitHub repo. And then we're adding a trigger here. So if there's a push and the branch is main, then we want to trigger the build. And then finally, we're creating here we're creating an execution role that will run on the build. So essentially, it needs access to code build, needs access to S3, and needs access to ECR. And then finally, here we're actually creating the code build project. This is where we actually need to specify the repo that we created up here as a build environment variable. And all this additional, including the role. Okay, and then down here, I have a bit of code commented out. So this is if you want to go ahead and take a stab at implementing the code pipeline. I will say, as far as I could tell, for for Elastic Beanstalk, they don't have an option for the free tier eligible version of Elastic Beanstalk. Like you have to use the like multiple kind of load balance deployment, which is why I kind of put the brakes on that. Also, it was taking a while, so I kind of ran out of time. But we will run this, and we'll be able to see that most of the infrastructure does build out. So then, before we do that, let's finish up with the backend here. So as the name implies, if we scroll through, we can see this is creating a DynamoDB table, creating a Lambda role, and then creating a Lambda function. And then down here, it's creating the API gateway with all those endpoints that we manually created the other day. And that's really it. So if we go ahead, I don't think. Okay, I thought we had to put the account ID here, but I think we're okay. It's in this file, isn't it? There we go. So let me go back and copy that and paste it in right here. Okay, so finally what we need to do is just run CDK synth. And what this will do is this will basically run this app and create a CloudFormation template from the app code. Oh shoot, actually it's not gonna work. Let's see what it does. The problem is that it's not, well, let's see. App is required either in command line or in these particular files, right? The problem is that I ran this in root directory and there's no app in the root directory. So we gotta do CD week 8, and then like that, and then we can do. So now we can see under the Cloud CDK folder, we have this CDK.json file that I was looking for. So this should work theoretically. Okay, so it says successfully synthesized two, and then it's giving me a file, and then it says supply this stack ID, right? It says either this stack or that stack to display the template in the command line. So let's just go ahead and look at the output file. So it says it should be right here. So we're going to look at the template for the regular stack. And we can quickly scroll through and see it does look like that cloud formation kind of template that we saw before. Um, so this theoretically you could copy paste this into cloud formation and visually see the architecture that way if you wanted to. Okay, but that's not super helpful, right? Like, I mean, theoretically we can do it, but like let's actually deploy something. So to do that, we would just need to run this command here, cdk bootstrap, and then we're using the stash dash profile to provide an argument, and then we are specifying the profile that we just linked to our new service account. So we press enter. And then this normally takes a second or two to run. Okay, so looks like it's already done. I think it's because I've run this command before. Uh, so then the final thing we need to do is actually deploy. So to do that, we're going to run this command. So we can see this is saying cdk deploy dash dash all to signify all the stacks in the project or in the app, and then we're specifying the profile again so that it actually has permissions. Okay, so this command might take a second because it has to provision a couple of resources. Um, okay, so let's look at see what it's asking. It's basically saying that I'm creating a couple IAM roles. See, IAM statement changes. And that's kind of like a dangerous thing to do, right? Because if you look at if we look at this Lambda role, right, for example, we're giving it full Lambda access and full DynamoDB access. Generally, that's not a good idea. Like you want to give it specific access to a specific Lambda function, and then specific access to a single DynamoDB table. But for now, just for testing purposes, we'll keep it broad. So we can just type in Y and press enter, and then let it run. Okay. Well, oh God. Okay. So we can see some of the things did not work, right? Very clearly. Uh, so if we look at this, we can see that this IAM role did not fail to create, probably because I've already created it before. We can see that this table failed to create, and we could see that it says this table already exists. So I probably didn't clean it up properly. Um, and then it says that let's see. So if we look at the actual error messages here, the problem was the table already exists. So and it was rolled back. So let's go ahead and go into the console, DynamoDB, and we're just going to delete the table directly. Okay, so the problem is I'm not in the right region. Okay, delete this. Okay, so now we should be okay. Okay, that looks better. It's clean now at least. Okay. Okay, so it failed again. Looks like the problem is with code build. I think I'm not giving it the proper um GitHub. Let's see, the GitHub repo. I think it should just be um yeah, the problem was that I was giving it the full link of the repo that I had in the ACM account, but it should just be the repo name that you have in your own personal account that you forked. Um, Let me quickly double check that because I believe if I look at the commits here, uh, probably this one is the one where I would have changed it. Uh, yep. Okay. So we can see that originally when I had it before, it was just that, right? And I changed it to be more generic. Let's go ahead and save and then run it one more time. Hopefully everything should work out. Yeah, what's up?
Do you know why, there would be the same like no one in the US?
Mhm.
Maybe they solve this big.
Yeah, I'm guessing that these things up here, the ones that are giving you problems, is that right? Yeah, you either need to activate the. So did you create a virtual environment or no? Okay.
But I'm like, I'm not in it right now because I'm
Mhm.
like, don't have to do it in like the cloud so you can.
Yeah.
You don't need a commit the folder to like activate the environment.
Yeah.
So I also think that like, it's like level three
Mhm.
has that as like a dependency for like, that's not from level three. So the second.
I don't think it is. I think it's separate. Correct. Uh. Oh, I see what you're saying. Hmm.
Because I think we installed AWS CDK with NPM, but that's like
Yeah, I see what you're saying. I think you're on the right. Basically, you need to what you need to run is uh let me just check to make sure it's right, but it'll probably be pip install with this. And I should update the README as well with that. A second. Yeah, if you run basically this command, that should get you everything you want. This may be pretty big though. So if you don't want to do that, what you can do is well, theoretically, what you could do is something like this, I believe. Um, and that would just install the first one, I believe. Let me double check. Ideally, you would be. So to do that, basically, let me sorry, the documentation this time was not quite up to par. What you'll need to do is to once you've created the virtual environment, if you're on Windows, I believe this is the command here, to activate the virtual environment, and then in your terminal it should say like virtual environment, uh, and then you know that it's running. And then you basically install all your libraries just in the virtual environment. So that way your regular Python libraries are not kind of cluttered up with all this extra AWS stuff.
So you might need to view like, CDK directories.
You don't need to be. I think best practice would be to create the virtual environment under it so that like it because you're only going to be using it for the CDK stuff anyways. but they're like, you don't necessarily, it's not strictly required. Yeah. It can be anywhere on there. Okay. Yeah, and I can help you out in a second with that. Do you have a question?
I think
Am I missing something?
stack in secret value in the USC. I don't think it's going to be I don't know if the zero thing runs.
Oh, I see what you're saying. So you're trying to install Stack, but it's not under AOCDK, so you're saying.
Yeah, I guess.
Okay. Try running it without, just try, so did you try running the full, like this?
Oh, yeah.
Okay. You may want to give that a shot. There's probably a way to do it. I just don't know off the top of my head. I'm sure we can look online after, try to figure it out. Yeah, just to kind of wrap up the recording though, since it looks like the everything was able to run properly, if we actually go back to the console and open up or just refresh this page actually, we'll see we do have the table. And if we, for example, for the back end, if we go to API gateway, we should be able to see that there should be a new a new API here. And if we click on it and click on this here, right, we can actually get the invoke URL and test out that all users endpoint. And we can see it does return an empty array, meaning it is searching through the database for those users. There's nothing in the database right now, so that's why it's empty. But theoretically, if we were to go and add those users to the database, everything would work out fine. And then for the front end, we can see if we go to ECR, we should have a new registry there. Okay, looks like I have a couple old ones. 29. Okay, I think this one here is probably the latest one. I don't think they charge you for just having registry. This one's empty, so it's probably the one, which is why it haven't been deleted. But I'll show you how to delete it in a second. Let's quickly check code build. Yep, we can see we have our project here. It's connected to my repository. And if we were to start build, everything theoretically should build properly and spit it out to that ECR repo. So ultimately, we were able to kind of create the front end and back end with just a single command, assuming we've entered in our proper account ID and have set up that service account properly. Okay, so the last step for us will be to delete those resources after we've created them. Theoretically, you could connect to the front end. I'm not gonna do that just to save time. So the final command you'll need is this one here. So this allows us to remove all the resources that were created from the CDK stack. Let's go ahead and run. Okay, it's asking me if I want to delete them. I'll press yes. We'll let that run. Ready, and we can see it's deleting with no problems, right? Which is great to see. So it finished deleting the backend stack. Now it's doing the front end one. Okay, awesome. So everything is gone now. And if we go back to the console and refresh, yep, it says not available, right? Okay, so that will just about wrap up what we have for the demo. I will go ahead and add those changes that the awesome people that came in person pointed out today, so that the README does work. If you follow the directions. The last thing that we have is a feedback form that was made. So feel free to scan the QR code or go to that link. Or if you're watching this after the fact, you feel free to fill it out. Just to kind of let us know what we can do to improve, or like other extra content that you may want us to cover. Like if the pacing has been okay. Yeah, and then next week we're gonna be kind of doing it'll be pretty chill. We'll just kind of go over next steps for an application like this or for cloud as a whole. We will have food, which will be cool, and yeah, it will be pretty chill. Okay, so let me go ahead and stop the recording, and we will wrap up.